Hi there. This is a video about the shearline DC motor and the speed control unit here. And I found that with the original pulleys on the tag, with the 1, 2, 3, with 6 pulleys, 6 speeds, and 6 speeds on here, when I erected it and set it up here, I was running the main belt on the center pulley from the motor and up to the spindle head, I thought that would work out okay, but I found that the lathe would stall if I put too much pressure on a cut, took too big a cut. So I thought there was something wrong with the control box, and so it's got some pots in there that you can adjust. And so I got on the computer and went to Shearline, and I printed off some details of the motor and the control box, and it gives a description in there in the form of a clock face of where these adjustable pots needed to be in position. So anyway, when I opened it up, I found that they were in the position that was called for, and so what was happening was that I would start the motor up and just turn the knob a little bit, and I would get the desired RPM that I required from that position on the pulleys. And I come to the conclusion that because I was only opening the speed control up just slightly and reaching my speed that I usually work at, which is between, I guess, 700 and maybe 1500 RPM. That's what I do usually in most of my work. I found that if I speeded up, I could get a better cut with removing more material. So it seemed to me that if you only open this up a little bit and try to work on low speeds, then the unit doesn't kind of work too well, and I presume that's because of the motor, the size of the motor. I think it's, I don't know, I have an idea it's supposed to be 1/4 horse, but it doesn't state that anywhere. I haven't seen anything. So so what I did was I changed the drive to the smallest pulley on the motor and the largest pulley on the spindle. And so then I found that to get my RPM, I had to open up this knob, this control knob, a lot more to, see I'm running at 600 RPM now, and I've turned it quite a bit more than I normally would have done. So I have an idea that that gives me more torque. The further that it comes up, the more torque, and I've now got myself running at lowest RPM. So to get to, see, that's, I'm going right the way round now, and it's only at 1000 RPM now. So I figure that maybe I've solved the problem, and I'm not really into electronics or electrics, and so I admit that I don't know very much about this kind of thing here. So it's kind of my theory that I was running on the wrong pulley, and getting it wouldn't take the cut. So what I've done now is I've got a piece of, at one point, this is old steel, I don't know where it came, what steel it is. I got a big box when I left the last job, and they had a whole pile of cuts in a big wooden box, and I brought it home when I left with permission. And so I don't know what this steel is, but it's this piece here is, it looks like it's probably hot rolled, which is not bad. I kind of like hot rolled, but as to what quality it is, I don't know. It's 1.450 on the OD, and what I've done is I've just cleaned up the surface here, and then I've just loaded up 100 thou just to see what takes place. I've put the feed on the lowest feed that I can get with the power lead screw tags. So I've been doing a few little samples, and I've got as far as taking a cut of I think it was 60 thou total, which is only 30 thou off the or 60 thou off the diameters, which is only 30 thou off of a cut. So now I'm going to try a 0.1 cut and see what happens. So I'll just start up now and see how it goes. Just clean some of this junk off. I'm so glad that I did something with the tailstock, making it like this. I could foresee I'd be having lots of problems with the original tailstock. So let's see. Okay, start it up. I'll run it at I guess 600. No, maybe 500. And you can tell that the torque is there, because when I take a cut, say I got it at 555 at the moment, RPM. Now, when I take a cut, that will drop down to maybe 4 or even maybe 3. So it kind of labours the motor a little bit, but we'll see how it goes. It's down to 475, 450. 370. It almost wants to stall, so I'm going to put the speed up a bit. So that's it. I'll put it up to, that's 900, 960, 950. It's gone down to 7. I don't like it. Doesn't suit me one little bit really. I've come to the conclusion that the Sherline motor is underpowered. See? Probably take a bigger cut than that maybe. Of course, if you grab the handle, it will stall. You've got to see, this is what I don't like about it. You have to allow the handle, when you're holding the handle, which gives you the feed, as soon as you release the handle it stops feeding. And even at this feed, the lowest feed, and running at 980, you have to allow the handle to reverse. You have to let it slide through your hand a little bit. So you have to adjust the pressure of the handle, which is what I don't like. That's that. Now, do another one. That's 100. $120, $130, 40, $140. move. Okay, we'll turn this around just like that. Try that. That's 90. That shouldn't be moving. That's moving quite a bit. Shouldn't move. What is it doing? Why is it moving this? So much junk here. Shouldn't move. Certainly it has more torque, no doubt about that. Now that's not bad. But how much is that? That's 20 thou. But that's nice. Nice cut. That's at 350. 360. Nice finish. Strange how sound changes. It's not doing anything different, just changes. This is just a high-speed steel tool bit as well. That's slow. thou. That's not unreasonable, I don't think. Give it a little drop of juice. That's 900 RPM, and that's 40 thou off the diameter. We'll try a 60 thou. That's quite nice. That's not bad. Okay, we'll try 60. 10, 20, 30, 40, 50, 60 thou. Oh, give it a drop of juice. Well, that's not bad either. Although it should take more than that. 60 thou. Let's make sure. Damn. So that's 260. So that should be 0.2 approximately. Yeah, that's 0.2. So that's 60 thou off the diameter. I wouldn't say it's good, and I wouldn't say it's bad, I guess. It's just a small lathe. That's 825 RPM. So 960. That's about 100 thou drop. 100 RPM, I mean. Terrible stuff. Need a chip breaker. Okay, well, we'll go to the, wow, So let's go do a run along there. Okay. Okay, let's just take a brush off we go. 80. 10, 30, 40, 50, 60, 70. We'll go 70 because we got the rough and bigger diameter. Oh, I'm machining.
Oh, you
I'm doing the video, yeah.
Oh, you're in the middle of it?
Yeah, I'm doing it now, yeah.
Okay, then you come, how long?
10 minutes? Okay. There we go. Okay, let's start again. Right down to, yeah. It just doesn't like it. Doesn't like it. Can't get it much tighter.